Hello, and in this video I'm going to go over how to generate Bootstrap confidence intervals for a correlation coefficient in I using the boot package. Although I'm going to go into some theoretical explanation, there's going to be much more about the pragmatics of actually doing it in R. So let's go over that theoretical explanation briefly. What we do when we do most inferential statistics is we collect some data, generate a test statistic for that data, and then compare that test statistic to a theoretical sampling distribution that has already been computed and tells us how likely or under what circumstances that test statistic is likely to be generated. And if our test statistic is sufficiently extreme, we either say that that's a significant result or generate what's called a confidence interval to assess the probability that if the results were replicated again, the amount of times that result would be or the amount of certainty that result would be seen again over an infinite number of replications. That's called a confidence interval. But that kind of logic relies on us knowing the theoretical sampling distribution, but for lots of data and lots of statistics we don't know the theoretical sampling distribution. So the idea of bootstrapping is let's use our own data set to generate many pseudo samples, or resamples are sometimes called, to reorganize our data under lots of different conditions, and so we can then use those replications to compare them to our data and use that to work out how unlikely or likely our data are. So that's the simple explanation. So, but say most of this other video is going to focus on the theory. So in this case, I've got two variables here: how agreeable someone is and how well adjusted they are. And I would expect these to be correlated, but I want to generate some confidence intervals using bootstrapping to see what the correlation is likely to be. And so using the boot package in R, I would just want to first load that package. So say library boot, and then if we look at the boot function, the help pages for it, this is a general function that can do any kind of bootstrapping for any statistic. So what it wants from us is to know where our data are stored, what statistic we want to generate, and the number of replications at a simple level. So when I initially did this, and what you might think to do is, if you want to do a correlation, there's a function in R called core that generates a correlation. So with that knowledge, I did something like this. So my data frame is stored in a data called D. The statistic that I want to generate is a correlation, so I said core, and number of replications is 5,000. But if I submit that, and then I want to open it, it generates me two statistics here that are my estimates, but neither of them are the accurate estimate for these data. So what's going on here? Well, that's the point of this video. It's to do with this statistic parameter here. You have to rewrite a function that even if you are using a function that's built into R, in a way that takes into account the bootstrapping. So let's do that. In my case, I'm going to define a new function just called core boot, and what that's going to take is the data and a sample. Now, when we pass this to the boot function, it's gonna automatically fill in these parameters for us. So it will know what data is based on what we passed in. What does sample mean? Well, sample means the specific iteration or the specific replication of our data that's currently being acted on. So that's what we need to do special. We need to make it so that the correlation or whatever statistic is being generated is generated specifically for that sample. So how do we do that? Well, the function for correlation is called core. So I'm going to say I want to run core. But what do I want to run it on? Well, I want to run it on whatever data is passed in. But this is where it gets different. We want to only run it on each time on the subset of the data that's currently being acted on. And what's the subset of the data? Well, it's whatever row, so it's the first argument, and so the row currently being acted on will be whatever's currently passed into this sample parameter. And we want both columns, so I'm just going to leave an empty parameter there. And because passing in a sample of data is going to, with two variables like this, is going to generate two correlations, one with each variable with itself and one with each variable with the other variable, we want to ask for everything in the first row and the second column of the resulting output of that function, and I can then just close the function off. If I wrote it correctly, which I just missed my closing curly brace. And now that I've defined that function, I can use that function in the Bootstrap function we discussed earlier. So even if there already is a function to do what you want to do, you need to write a custom function to do it for Bootstrap. And so instead of saying core, I'm going to use my default function, which is core boot. And if I now ask for the results of that, I now get one correlation, which is the actual accurate correlation. And how do I get confidence intervals so I can make inferences about my correlation? Well, I just say boot.ci and then give it that results object. And it's going to tell me that my 95% bias corrected accelerated confidence interval is anywhere between minus 0.035 to plus 0.4240. So, or another way to look at that is it's not significant because the confidence interval crosses zero. So that was just an example of how to generate a Bootstrap confidence interval in when it says statistical function even if there is one that already exists, you need to rewrite it so that it takes account of those two parameters. The one being whatever data the user passed in, and two, critically, only do it once for each of the samples that each of the Bootstrap samples that are generated. So, hope you enjoyed this video, and I'll see you in the next one. Bye bye.